Hey everyone, and welcome back to the EdgeVerse Techcast, your go-to place for everything related to NXP software, tools, and enablement, specifically tailored for NXP processors and microcontrollers.
Now, Bridget, if these people have been listening to this show for a while, I think they're starting to get the hint. We've been talking about security for more than just a few episodes. It's a theme that is popular, we're getting a lot of activity, and honestly, Bridget, it's for a good reason.
That's exactly right, because security is no longer this isolated feature developers think about at the very end of a project. It's becoming foundational to connected devices, industrial systems, AI at the edge, and even long-term product lifecycle planning.
And we've noticed there's a big change in how the conversations start. When I started working on security a long time ago, a matter of fact, with our guest speaker today, there were a lot of conversations happening, but it was very simple. It was like the beginning, or maybe we'll say tip of the iceberg. They were asking us about secure boot, or how do I protect my IP and send it over to an unsecure manufacturing facility? But now it's way more complex, which is why we're having so many different episodes. Customers are asking bigger questions. They're trying to find answers for cyber resilience, secure provisioning, device identity. People have been asking us, how do I do remote updates with my products so that I can be regulatory ready?
And today we wanted to build on some of our earlier security discussions and bring in someone who works directly with customers every day.
And as I hinted, I have a history with this young lady. Joining us today is Wendy. She's an FAE at NXP who helps develop with our customers. It's really important in the real world to have these excellent engineers to help our customers handle these embedded security challenges. So we're really happy, Wendy, that you joined us today to help us explain what the customers are going through.
Wendy, welcome to the show.
Hey, thanks so much for having me. I'm excited to be here. Kyle, it's always great to work with you. I've been at NXP for about 4 or 5 years now. I am focused on MCUs with a strong focus on security and security systems. So happy to be here.
Awesome. Happy to have you, Wendy. As I mentioned, a lot of developers have heard terms like hardware roots of trust, secure enclave, or lifecycle protection. And immediately they think, hey, we need to implement the most advanced security architecture possible from the start. So when customers come to you, Wendy, and they have this great idea and they have these concerns about how they're going to implement security, where do those conversations usually start in the real world?
Well, one of the things I like to first understand is where the security requirements coming from. Are they a marketing blurb, or is it something you've decided as a company? And this helps kind of start the conversation. And I think two of the biggest things when really looking at a security system is first, the importance of understanding what level of security makes sense for your system. And second, really try to encourage people to define their security requirements at the beginning of the design, when they're really architecting out. This is when you have the most control of everything. Security features cost money in both silicon costs and design time. The more security features you have, the higher cost of the silicon, and also the longer it's going to take to implement those. So knowing what you need and where you're going is really important as you start. And as we begin to look at this, let's take a look at two designs. Let's start with a modern day child's toy piggy bank, and it has an MCU in it, and the MCU controls access to the cache of the piggy bank. So that's one design that you might want some security features with. And a second one could be a security system protecting Fort Knox. So both of these designs benefit from some security, but what they need is very different. When we take a look at the child's piggy bank, as a company who's made this product, I want to protect my IP and my reputation, and I want to ensure that customers receive a quality product. As such, I want to ensure that the software that's loaded into the product is known and works as expected. Thus, I probably want to have a secure boot initialization and a secure debug control. So with the child's piggy bank, I'm looking at a very basic level of security. Now, when I look at Fort Knox, I need top-notch high security. I need hardware root of trust, data protection, enhanced protection against hardware attacks, and the list goes on.
So what you're saying in this scenario is you're protecting more than the bacon.
Well put, Kyle. Very well put.
Yes, yes.
So the conversation when I'm talking with a customer, it really starts with, what is your system? We gave two examples. We gave one of a child's piggy bank and the second one, Fort Knox. The next question that comes up is, what are you trying to protect? For the child's piggy bank, you're really looking to make sure that the software that is loaded into your device is quality and people know what they're getting. For Fort Knox, this is an electronic door access into its vaults, its buildings. We need something highly secure. The next question is, what happens if the device is compromised? When we look at the child's piggy bank, it's really down to kind of a loss of corporate reputation and products that people don't want if this product doesn't work well. But when we're looking at Fort Knox, the risk is astronomical. We're looking at a military base, gold stores. We can't afford to lose. The risk is extremely high. Another way to look at it is really, what kind of product is this? Is it a consumer product? Is it an industrial controller, medical device, or something with a critical infrastructure? As we look at these questions, they're really going to guide us towards what type of security system we need.
I actually really like that idea because it makes security feel less like a giant mountain developers have to climb all at once.
Bridget, that's a great way of looking at it. It's really about understanding what makes sense in your system and building the right foundation for your security architecture.
One thing I found really interesting is this idea that security can scale depending on the application. So, Wendy, what does scalable security actually mean in practice?
Bridget, it has a lot to do with the examples we've actually already talked about. With the first example, we had very basic security. And with Fort Knox, we were at the opposite end of the spectrum. NXP understands this, and we really try and put things in a general way of four categories: basic, essential, advanced, and high security. For some applications, basic security features like secure boot and secure debug control can be enough. And this is really where our modern day piggy bank example came in. When you're looking with something that needs a little bit more security, like our essential security, we want the same features that we had in our basic security, but we probably want to add things for execute authentication and ensuring only authorized firmware and software can be loaded into the device. We might be looking at managing access based on cryptology. This might be more than just the debug ports, but also access of users or at the OS level. We might be securely connecting to other devices and remote cloud services. We might be looking at encryption and authenticated data on the device.
So, Wendy, I think you made it pretty clear the basic, essential, and how we build. Can you talk a little bit more about the advanced security and the high security categories?
Advanced security is really using the level of essential security, but what we're adding in is solutions that are using like our EdgeLock Secure Enclave. And this has enhanced protection of integrated security functions such as authentication, attestation, and secure connections. And depending on the IC, we may have such things as device state monitoring, runtime integrity protections, and or actually physical tampering monitoring. The next level, the highest level that we're talking about, is the one that we've talked about with the Fort Knox. This is our ultimate security system. These solutions include protection of credentials against hardware attacks by adding something at one of our companion secure elements or a secure authenticator. These are solutions like our example with Fort Knox, where we're really at the ultimate, the highest security level that we need. When we're talking about the flexibility, we're really talking that you need to take a look at your design, see what is important for this design, and to scale accordingly. And NXP has a wide variety of solutions to help you out with that.
So what you just went through, Wendy, shows that one size does not fit all for security.
In no way. Exactly.
Yeah.
It's definitely a look at your system, what makes sense for what your system is.
All right. Well, perfect. Thanks for outlining the different tiers of security. Now, let's talk about some of the terms. The first term that always comes up in conversations that we hear is this hardware root of trust. With all the experience you have with your customers, can you explain for the listeners in plain English, what in the world does this root of trust? I always think of a big oak tree, but I don't think it has anything to do with that. So can you explain to the listeners, what is a hardware root of trust?
Kyle, actually, a big oak tree and its root system is a great image to add to this.
All right.
So, the root of trust is the anchor, the root, the integrity of the whole system. It means that you're starting from a known place. When we talk about a processor or an MCU as being the hardware root of trust, envision the processor in a system. The MCU has immutable ROM on board inside the silicon, as well as an isolated security core. So when we power up this device, there's a power on reset. As soon as that power on reset is seen, the first thing the MCU does is it goes to its internal ROM, read-only memory. Inside the ROM is mutable boot code defined by NXP. This is where the hardware root starts. The ROM code is implicitly trusted as it can't be modified by an attacker. Once we boot into this ROM with NXP's defined code, next we want to load a software image from Flash. This image in Flash can't be trusted because it may have been modified. So it's the ROM code that has to verify the authenticity of the software image before we load it. Once the ROM code verifies the authenticity of the image, it enables the software image to run. If it's unable to verify the authenticity of the software image, it will not enable the software image to run. So using the boot ROM embedded in the MCU, as well as the MCU's isolated and dedicated security core, we've built a hardware root of trust where we always know where we start and only enable verified software image to run on the MCU. Without this hardware root of trust, the system could be compromised. With more and more devices being connected, clouds, networks, etc., the device integrity and trust are becoming more and more important.
So this is basically helping establish trust before the device even fully boots up.
Exactly, exactly.
Okay, now let's get into one of the coolest sounding parts of this discussion, the EdgeLock Secure Enclave. What makes this different from more traditional approaches?
So the EdgeLock Secure Enclave is NXP's integrated hardware system. It's basically what we just talked about. It's that dedicated and isolated security system inside some of the NXP's MCUs and NPUs. It acts as that hardware root of trust for these devices. It has its own CPU and core memory. This own CPU and core memory can't be used from the application. It's isolated from the user. This keeps sensitive assets away from the application cores and runs all the critical security functions in an isolated environment. And as I said, the developer does not have access to this core. Its purpose is to protect the platform integrity. And by managing the core device security functions, such as secure boot, lifecycle management, debug control, key management, and cryptographic services. The EdgeLock Secure Enclave is the boot ROM that we talked about earlier.
Okay. So everything you said, it sounds like we're just giving our secrets their very own heavily guarded VIP room that people can't get to.
Great analogy.
I wish I could get into
Very,
that private room.
it's very exclusive access only, Kyle.
Yeah, I'm not getting
You're
in
gonna
there.
have to get the secret code from Wendy. So last question, and we always try to highlight this on the podcast, and that's developer enablement. Because security can sound intimidating until developers actually see the tools, the software, and the resources available to help them get started. For the developers listening right now, what does the onboarding journey typically look like?
As we talked about earlier, you really want to start with what's your goal with security. The key is to define the security requirements at the beginning of the design. Look at your system, understand what you're protecting, and understand what happens if the device is compromised. Because there's a lot of cool security features, but back to the child's piggy bank, there's no sense in putting a Fort Knox level security there. Once designers know exactly what their security requirements are, they're in a position to start looking at what processor works for them and may scale best through the life and feature set of their product. NXP has a great variety of MCUs and MPUs to meet security system needs. And just encourage people to reach out to us if you have any question, because we're happy to work with you to help find that best MCU or MPU security system for you. Once you have the MPU and MCU defined, NXP has a variety of enablement resources to simplify the process. We have application notes, reference manuals, tutorials. We have a tool called MCUXpresso SEC Tool. This provides a GUI interface to enable secure boot and block unauthorized software. It's simple to use, really simplifies the process. It takes just 6 clicks to ensure that you have enabled secure boot and blocked unauthorized software.
Now, what about the example code? I know we have some example code offered in the application code hub. Can you talk about some of the applications that are in there?
Yeah, we have a lot of great software applications example code for you. We have debug authentication, memory block checker, also known as our MBC, glitch detection, TRNG examples, tamper detections, secure firmware update, and other features. We really have a lot of great ways to start and to help you guys get up and running.
And we have a great FAE in the Pacific Northwest called Wendy Warne. So
That's right.
I think NXP's done a pretty good job loading the deck to help people get started with security. All right. Well, I actually think it's reassuring for the developers because the security sometimes feels like it's this huge list of stuff they have to consider. But after you described it, Wendy, I think that you've really helped them understand some of the more complicated decisions they have to make.
Thank you. Yeah, security is new. There's a lot of features coming out all the time. It can feel overwhelming, but just start with what you need and work with us. We're here to help you and to support you.
I think that's a really good takeaway from today's conversation, that security is becoming foundational, but developers don't have to tackle it alone. Wrapping up for today, Wendy, thanks again for joining us. And I think one thing I really appreciated about this conversation is that it made security feel much more approachable and practical for developers.
That's really the goal, Bridget. And thank you so much for having me. Again, security feels complex, and it's really about understanding the risks, choosing the right protection, and building a strong foundation based on what your system needs.
Yeah, and I think the listeners will understand now that security is no longer just about that simple feature. It's becoming part of the overall system architecture. You said they have to start from day one, and it works all the way through the end of their life cycle of the product.
Especially as edge devices become more connected, more intelligent, and expected to stay deployed for years in the field.
If listeners want to learn more about this topic and learn about scalable edge security, the topic of hardware roots of trust, the EdgeLock Secure Enclave, what is it?
Enclave.
Enclave.
The EdgeLock Secure Enclave, and NXP Security Solutions, we're going to put some of those helpful resources in the show notes.
And as always, thanks for listening to the EdgeVerse Techcast. Don't forget to subscribe on your favorite podcast platform, and we will see you on the next episode
of the EdgeVerse Techcast.